So this is our 4th week. Like we mentioned, we have 2 more weeks, and we're basically going through all the modules in the Azure SQL Fundamentals learning path. And, Bob, just a quick recap. Can you take viewers through, what we've done so far and what's still to come?
Sure. I mean, we built this in such a way that we thought everything built on each other. And so if you start with just what is Azure SQL, get introduced to the topic, how do you compare that to SQL Server? What are those options for you? SQL Server and Azure Virtual Machine, Managed Instance, and Azure Database. When would you choose these? When does it make sense to pick one versus the other? And then you got to start by deploying the thing or installing the product, right, and configuring it just like SQL Server. So that's why we did that in week 2. And these next 3 modules, we did security last week, or the meat and potatoes. Remember that one, Anna? The Texan term, right, of SQL. They don't go in any certain order, quite frankly, to be honest with you. It's not like security, performance, availability have an importance versus the other. They all kind of go together, but they're really at the heart of the course of what you learn about this. And then, of course, today is about performance. And then, we cap off next week by talking about availability, a really cool part of Azure SQL as well. And then we'll have that great last module where we kind of put everything together about everything we've been learning.
Yeah, it's going to be a great module. And if you want to follow along with us after the session, this is the Learn module that we're covering today. It is part of that learning path that we talked about, and you've probably heard us say in previous episodes that we've heard from the community, we've heard from multiple people that by going through this learning path and going through this Learn Live series with us, you can go do things like pass DP300, which is the certification exam for administering relational databases in Azure. So this is something to know, that all the demos Bob does today are going to highlight exercises that you can actually go complete yourself in Microsoft Learn for free in the built-in sandboxes that they have. So that's definitely something you're going to want to check out after the session. And I also want to remind you that this is live and meant to be interactive. If you haven't joined us before, you'll be excited, hopefully, to learn that we do have lots of knowledge checks throughout this whole thing. So we'll be quizzing you as we go. And we also have some subject matter experts, so other members of our team, standing by to answer any questions that you have. We encourage you to head over to Learn TV to interact with us. That's where all the knowledge checks will be taking place in a more formal way. But that being said, if you're streaming in from somewhere else and you don't have head over to Learn TV, we will also be monitoring the questions that come in there as well. Please ask your questions, make comments, let us know what you think throughout. That helps us keep it a little more engaging since we're not actually all in person today. Now, with that, we're going to get right into the module, which is performance. We're going to do just like we've done for security and like we will do for availability. We're going to start by talking about the capabilities and the tasks. So you want to know what's going on with all these things you're already familiar with in SQL Server when it comes to performance, and how do those capabilities come into play when we talk about Azure SQL Database and Azure SQL Managed Instance. And once we kind of understand the capabilities, then we're going to move into the task. So how does this apply to you? How can you configure and maintain for performance? How can you troubleshoot performance? What are some of the monitoring capabilities that you have in Azure today? I think Bob actually has a really cool new Divo to show you all, really kind of hot off the press on that one. But when we think about performance overall, Bob, what really stands out?
Well, a lot of people do ask me about this specific topic about performance with Azure SQL compared to SQL Server. And they're a little bit concerned that they don't have the same capabilities with Azure SQL that they get with SQL Server. And I tell them that's just not true. I mean, all the capabilities exist there today that you use with SQL Server. There are some differences, though, you got to be aware of. So, for example, with a SQL Server deployment, you usually go try to do a sizing exercise, right? You go figure out, what are the capacities I need for resources, things like database size, number of cores or CPUs, how much memory. Think about SQL Server as a resource. You need CPU, memory, and fast storage to make it a really great experience for your application, right? So you go through the exercise of looking at bare metal servers or virtual machines for that. But it comes to platforms as a service, you don't have access to those resources. So how do you do this, right? And we talked about in previous modules that we've done in this series about service tiers, right? And compute choices and so forth. So I thought it's kind of interesting to go look at the maximum capacities. Now, this is kind of changing. This is an evolution for us, and we're kind of always building and making enhancements here. But today, if you look at your availability possibilities or your performance capabilities for Azure SQL Database, depending on the hardware generation you pick, you can get up to 128 cores and 4 terabytes of memory and 4 terabytes of database size. A lot of people don't realize that's possible. That would be, for example, like your general purpose tier using like the M series, for example. But hyperscale, we've mentioned that, certainly that option before with Azure Database, go up to 100 terabytes and quite frankly, unlimited storage capabilities using Azure SQL Database. Now for a managed instance, today the capacities look like 80 cores, about 400 gig of memory, and 8 terabytes, although we're looking very quickly to try to expand that size as well. And then we're going to mention this DMV OS job object. I mentioned before a little bit in a previous module about what a job object was, a concept under the covers. We're using Windows Server to restrict the resources that a particular VM gets or a process gets in a VM. And we do that with Azure SQL to make sure we maintain these capacities. So that's the maximum capacity for this. So what about indexing, right? Like, what about indexing? So all indexes are supported. This is a thing that people forget. You know, your performance skills with SQL Server definitely apply still in the cloud. I'm going to talk about auto indexing at the end of the session today, but all those indexing things you're used to doing, online indexes, resumable indexes, column store indexes, very important concept you still should be paying attention to. Those are all supported for your use today in Azure SQL Database and managed instance. So don't have any fear that you can't do that. I do recommend that if you have like specific jobs you run and so forth to maintain these things, that you ensure that they run well in the cloud. But all that kind of type capability is there. Now in memory OLTP, a specific capability for low latency type transaction needs for an application that exists today in SQL. Now today in SQL Server, that's in Enterprise Edition and to some extent in Standard Edition with a little limitation. You need a business critical tier, whether it's in database or managed instance, to get that capability. But we do some things for you, like we'll auto create the file group for you, and then we fix the amount of memory you need for those capabilities within your overall memory limits and your capacity for your service tier. So that's one aspect of this. What about some other parts of this? Partitions, a very popular concept in SQL Server today to partition out data. That exists for database and managed instance. Now, a lot of times people will take partitions and place them on file groups to put them on specific storage drives. You don't get that capability with Azure Database or managed instance because you don't control disk storage placement of files. In fact, the whole idea is that you don't have to worry about that anymore, but you still can use partitions as a concept in database and managed instance, and a lot of people still like to do that. In SQL 19, if you remember back, I keep saying Anna last year, but that was really 19.
Right.
We launched SQL Server 19. We had some pretty cool performance enhancements in that release, but a lot of people don't realize that a lot of that was in Azure SQL first, intelligent query processing being one of those. And towards the end of the session today, you know, we'll cover what is intelligent query processing and go over that. So I think it's kind of important for folks to see this slide to say, you know what, a lot of the stuff I'm used to doing in SQL Server, it exists in Azure SQL. Just because I'm on platform as service doesn't mean I don't get the full capabilities of the SQL Server engine. So it's kind of important to see what's possible to do that. So we talked about configuration in Module 2 overall for Azure SQL. But as you look below here in our breadcrumbs that we have, we're going to talk about configuration and maintenance specifically for performance for Azure SQL. Then we'll talk about monitoring, a very important topic. And you see the various other things that will go down the list during today's module and do some great demonstrations for you as well. So configuring performance. When I thought about building this slide, I thought, what are the things that I should highlight for configuration performance for Azure SQL Database and managed instance? This is not everything, but I think it's really some of the things that you should pay attention to because it could highlight some of the differences, even though the capabilities exist the same for SQL and Azure SQL. It all starts with TempDB. Certainly not a controversial topic in the space of SQL family and SQL land is configuring TempDB. But here's some interesting things for you. First of all TempDB files are always kept on local drives. So don't even worry about I/O performance. You know, we're going to put these on local drives, SSD drives for you, so I/O doesn't become any issue for any situations with TempDB. But usually what people are concerned about most is not that. It's about the number of files that you get to partition out our allocation pages to avoid latch contention. And for Azure Database, since it's a fully managed database service, we will pick the number of files for you automatically, and we'll scale that with the number of vCores. It kind of makes sense. The more concurrent workloads you might do, the more files you might need, so we do that automatically for you. Now, in managed instance today, you just get 12 files, but we are specifically looking to have a similar experience for database, or even allow you to do more configuration with it like you do with SQL Server in the future. Some of the options used for the database, which used to be trace flags, that stuff's just on by default, just like SQL Server. And today, empty metadata optimization, which was in SQL 19, is not in a managed instance today, but we're looking to actually see if we can support that. Kind of just get rid of any of that latch contention issue you may worry about. Overall, though, I would say the message is TempDB is pretty configurable and auto-configurable in the cloud for you. So that's one aspect. What about just databases alone? Now, this is not just configuration for the database for anything, specifically for performance. And one of the areas people concern themselves is minimal logging for bulk operations. Very important to call out that only full recovery supported. It's configured automatically for your databases, both for a managed instance, both for Azure SQL Database, and you can't change that. Well, why is that? You're going to find out in the next module next week that for availability, we have something called a service level agreement, and we need to use full recovery to ensure we keep you highly available. So keep that in mind. Minimal logging not available for you. It is available in TempDB, and you all have the ability also to things like bulk load it with column store indexes to improve that efficiency. Now, the third area that I picked was files and file groups. So with Azure Database, you don't worry about that. But for managed instance, you do have the ability to add files and change sizes of files. You just don't physically place the files. Now, you may see that point and go, uh-oh, that's a showstopper for me. I can't use Azure SQL. Well, I'm here to tell you that when we're going to talk a little bit more about scaling performance, we have specific resource and service level objectives for I/O performance, whether it's latency or IOPS or overall I/O throughput, that you get depending on the service tier and the vCores you pick. So I have found that many customers kind of like the fact they don't worry about this anymore. We place these files, but then we have these resource limits and level objectives that we give you depending on the choices you make. Now, having said that, for managed instance in a general purpose tier, we're going to be using Azure Storage behind the scenes. So it turns out that the number of files and the size of these files you pick could increase I/O performance, a very specific set of documentation to give you guides on this. And the reason why is that depending on those choices you make, we may pick higher level premium storage disk sizes, which have better IOPS or better I/O performance. So keep that in mind when you take a look at managed instance. And then just keep in mind, if you want to use file groups, again, you wouldn't use it for file placement, but to just organize your objects, you do get that capability to user-defined file groups for managed instance. Now, max degree of parallelism, which we also call max DOP, another non-controversial topic in the SQL family. Some good news here for you. Number one, we do pick some defaults for you, but alter database scope configuration exists for you to make changes to this, both for SQL database and managed instance. Now, if you want to change this at the server level, remember, an Azure database is not a server instance for you, even though we may use that behind the scenes. So SP configure is only available on managed instance today, but you get query hints. Managed instance does support resource governor, so you can change it there. And then we're looking to decide in managed instance, should we change some of the defaults we're using to actually help make it easier for you. Now, for resource governor, that topic alone, a lot of people like to use that capability to do things like limit workload groups and tie it to an app for things like I/O, CPU, et cetera. And that is available to you in a managed instance. Again, that is one of the promises of managed instance, to give you that instance level type capability. And resource governor is one of those features that we do that. Now, I've mentioned before in previous modules that we use resource governor behind the scenes to do certain things, but the actual resource governor T-SQL is available to you in a managed instance, again, for pools and workload groups. So that should give you kind of a feeling, Anna, about what are all the different things that I should concern myself with configuring for performance for Azure SQL.
Yeah, it definitely does. So thanks, Bob. And I'm going to throw up this first knowledge check question, but I do have a question for you as we kind of let people kind of look at this question. You showed us a lot of the capabilities and in many ways, like things that are kind of set by default and ways we can change them. Like for the most part, do you think we set things like at random, or do we use some sort of best practices when we go and set these things? And do you have any guidance around when you might actually go and actually change some of these capabilities or default settings?
That's a great question. And it comes down to what we talked a little bit before in our deployment and configuration module. It is your choice of product, service tier, compute choice, hardware, things of that nature, and your vCore choice, remembering the vCore model, that kind of dictates a lot of these defaults that we pick. So I would say, in general, when you make some of those choices and you look and see what are we configuring for you, a lot of these things are just set up for success for you, just to use. But the managed instance one's a great example where we're taking a look at customers that are contacting us, because we use max.0, by the way, in managed instance today, which is just use degree of parallelism at will in SQL Server, right? Whereas in database, we don't do that. But in managed instance, we're doing that. So we're taking a look at it saying, customers are struggling with this. Why don't we just set it to 8 or some number that we think is a good default number so people have less problems? Because we're trying to promote the idea that it's a managed service, right? So it's a great question, Anna. I think these choices you make for service tiers, for vCores, et cetera, are going to dictate a lot of the defaults that we're going to set. But I always want people to know that you do have some capabilities of making some configuration choices in case those defaults aren't appropriate for your app.
Awesome. Thanks, Bob. Yeah. And I think it makes sense to kind of, we're going to try to figure out what's best. But then, the great thing is that you have this flexibility to try to meet your scenario where it needs to be, and we're not so fixed. Okay. So let's take a look at this first knowledge check question. Hopefully people are ready for it. It is a Monday, but the question is, the number of files for TimDB is configurable for Azure SQL database by which method? So go ahead and head over to LearnTV and put your answer in the poll and let us know what you think the answer to this is. Bob did mention this at the beginning of the last slide, so hoping we're going to be able to start off strong here, Bob.
Yes. Anna, I'm sure, Anna, I'm really proud of you though, because, again, remember, you're the professor that people generally would prefer not to get because you ask these really hard questions. And this one I think is pretty straightforward. So I'm kind of hopeful. I haven't seen the rest of the knowledge checks, but I'm hopeful today that you're not throwing just these really tricky, hard things at people on a Monday, for gosh sakes.
Yeah, exactly. Yeah. That's true.
Yeah.
We'll try to keep it relatively not tricky and annoying.
Yeah. I don't believe that. I don't believe that. It's we'll see.
We'll see. We'll see what happens.
Yeah.
Okay, let's go ahead and we got some answers in. Looks like most people are saying C, increasing the number of vCores through the portal. But some people are saying using file properties in SSMS. Can you take us through the answer for this one?
Well, if you remember, Anna, we kind of use this process of elimination idea. And this is Azure SQL Database. And I specifically called about some configuration choices for managed instance. But I mentioned that for Azure Database, we just picked this thing for you, right? So it's configurable though. And I mentioned how, and it was a scaling thing. So alter database statement A cannot be the answer, as it turns out the file properties in Management Studio just uses alter database. So the B can't be the answer. So C must be the answer. And that is, you just mentioned it. We picked some defaults, but you configure it. And one of the ways you do it with Azure SQL database is through number of cores that you pick. So it has to be C. We're going to scale files for you as you add more cores.
Awesome. Yep, that is exactly right. So well done. Off to a good start to most of our viewers and you as well, Bob. We're going to go ahead and put up the next knowledge check question. So we've got a few now before we keep going through the performance content.
Okay.
And this next question is kind of similar in what it's asking. It's saying you can configure I/O performance for Azure SQL Database by which method? And while you all take a stab at answering this question, I do want to call out, someone commented that this is not live. This is very much live. So
oh, it's not live? Oh, so I recorded this yesterday or something. I just hey,
so we are live.
Look at my shirt I'm wearing. This is live. I'm getting ready for tonight. This is live.
It's funny. But yeah, we are very much live, and we do have members of our team standing by to answer your questions. So please put in your questions now, because our team is standing by to answer those questions live, because this is very much live. Okay. Sometimes I have to warn Buck that on shows, that a reminder, this is live.
You don't have to warn me. I'm not Buck, so I get it. So.
Okay, so we've gotten some answers in, a few answers. Seems like people are between B and C right now.
B and C. Okay, that's what they're saying. Okay. Okay.
I think if you want, Bob, you can go ahead and take a stab at taking us through this one.
Sure. So you can. So the question is, you can configure I/O performance for Azure SQL database. Okay, that's what you said, Azure SQL database, and we specifically said several times, placing objects and file groups. First of all, you can't use file. You don't get user-defined file groups in Azure database, so it can't be C. But remember, you don't get to place files anywhere with Azure SQL database, so it can't be A. Because we may use Azure storage behind the scene, but you don't know that. As it turns out, we actually do, but for like general purpose. But you don't get to make that choice. That would be something you would do, for example, in Azure Virtual Machine, right? So it can't be A. So it's got to be B, which means what? Remember we talked about this. What is the service tier? What are the different things you pick? And then we have certain objectives for IOPS, IO delays, IO throughput, all those kind of things.
Awesome. Yeah. And it seems like we ended up getting about 75% of people got that one. So we tricked a few people, but I think most people are on board so far.
Well, Anna, one of the things I think that was tricky there, just real quick, is I said specifically for managed instance that the number of files and the size of files could affect IO performance because of the size of Azure Premium Storage we pick on the back end. But we do that for you. You don't place files there. We just do and place files for you. You don't know what storage we're picking, but we do have some documentation that the number of files and size in managed instance could affect this.
Right. But for Azure SQL database, it does not.
Correct. Yeah, we're doing all that for you. We have objectives that give you the performance you need. That's correct.
Awesome. Great. Now, as we move forward, we talked about some of the capabilities. We talked about configuring for performance. I think the next topic really is, how do I maintain for performance? All these things I used to do.
Yeah, I thought about this topic some as we're building configuration maintenance. Because again, remember what we're trying to do. We're trying to understand and relay to you what are the tasks that you do today for performance, and then how do you translate it to Azure SQL, right? So when you maintain performance, there's a lot of things you do maybe, but it really comes down for SQL databases to these tasks, right? I maintain indexes, I either rebuild or reorganize them, or I maintain statistics. And here's the great news. This all just works like SQL Server. Now, it could be very controversial for you to decide, do I need to do it? Do I need to rebuild indexes anymore? Do I need to reorganize indexes? Should I use auto update stats? Should I update my statistics? And that's a whole entire series that somebody probably could do for us, right? I'm not here to kind of debate that or discuss with you what you should do. I'm just here to tell you that all these options exist for you. Now you're going to see, for example, on the index side, again, at the very end, we'll talk about some things we're doing in the Azure database space to help this automate some of this. But if you need to rebuild, reorg, online, resumable, auto stats, update stats, all that stuff just works for you for Azure database and managed instance. Here's the good news, Anna, is that if you have a bunch of tools behind in your tool belt to do these things, this is just going to work for you. Now, you may need to schedule it a little differently. Azure database, you might use Elastic Jobs because you don't have agent. Managed instance has agent, right? But all the T-SQL you use here is just going to work in the cloud for either one of these options.
Yeah, I think that's kind of a theme that we like to harp on when it makes sense. And that's, it's just SQL. And that's a great example of that. Okay, so we have another knowledge check question. This one is, I think, a pretty good softball. It says, how do you maintain indexes with Azure SQL? So Bob, just talk to us about this. So take a stab. We're going to put up this poll. And in the meantime, let's see if we have any questions that have come through. Remember to keep your questions coming in. We have someone from India saying, thanks for sharing all the great knowledge. It's really our pleasure. I think Bob would agree with me. We're sad we can't go travel around the world right now, but we're super excited to get to share this information with you all.
Absolutely.
And we have some people sending their answers in.
Okay.
Looks like people are pretty split, actually, between A and B. It looks like maybe A is starting to take the lead.
Okay.
Keep your answers coming in. And remember that theme that we talked about. It's probably a big hint, but the it's just SQL theme.
Okay.
Okay, Bob, we got some votes. It looks like 83% of people have said A so far. So I think you can go ahead and take a stab at taking us through this one.
Yeah, let's eliminate it, right? So look at C. I just said everything's supported, right? So the word not supported shows up. And you didn't say Azure SQL Database or Managed Instance here, which was very open-ended of you, but that was clever because I also said both for these are possible. So C can't be it because we just said you can do offline, online, all that works, right? Same thing kind of for B. It just worked. You can rebuild indexes anywhere you need it. So B can't be the answer. Therefore, A has to be the answer. But I did emphasize that. And why did we do this knowledge check? We want to just keep emphasizing to you, you get to do the things you want to do with indexes with Azure SQL, just like SQL Server. So don't fret. Again, you should study and look at whether you do need to rebuild indexes. That may be something you need to revisit. But if you need to do that, all those capabilities exist there.
Definitely. Okay, so we've talked about the capabilities. We talked about configuring for performance. We talked about maintaining for performance. And I think the next really big topics, these are all really big topics like you mentioned, is really around okay, how do I monitor what's going on with performance?
And there's probably no more bigger topic in this space than this right here. And that's monitoring performance specifically. And again, I've seen people come to me and say, I'm very concerned. I have a specific set of processes and tools I use in my data center. It's not going to work in the cloud. I'm really worried. Or my skills are gone because I used to have all this expertise to monitor performance. I'm here to tell you that none of that's true. Now, for Azure SQL Database and Managed Instance, it's platform as a service, right? So it's not like you're running perfmon and just looking at the thing, right? But we have some capabilities you're really going to like. So first of all, Azure Monitor is an ecosystem. It's part of that Azure ecosystem we talked about early on to monitor metrics, get alerts, do logging for important telemetry for performance for Azure SQL. And look at this new bullet point, Anna. Here I am today to add something new. SQL Insights. Our friend Elaine Dormal is just going to love this. Hope Lane's online listening. We have announced a public preview just recently for something called SQL Insights. You're going to see a demonstration of that today. And the idea is that let us go help you here. Let us go build a monitoring machine in the Azure Monitor ecosystem to help you monitor your Azure SQL assets. Let's light up for you all this rich telemetry that you're used to seeing inside SQL, and let's do that outside of SQL. So I think you're going to love what you're going to see there. I'm going to show you a demonstration of what's possible for you. It's got a really cool story because not only is there visualizations here, but the extensibility is amazing. And we're going to use open source software called Telegraph in a virtual machine to monitor Azure SQL, all of your Azure SQL assets. And then you can actually see these in log analytics and workbooks. You can get it. You yourself can go see the Telegraph queries we're actually using. So it's a very extensible framework. It's open source, and it's really, really cool because people that use and love things like perfmon are going to see this and go, oh, finally, that's what I've been looking for. So we'll show that off today in a demonstration. Awesome. But remember, Anna, that's outside your SQL deployment. You then connect inside SQL, and you're wondering to yourself, do I get dynamic management views? Do I get extended events? Well, we're here today to tell you yes, and you get more. You get the same SQL capabilities you get in SQL Server, plus some additional things that make sense specifically for the cloud. Now, lightweight query profiling, a very feature of SQL Server that's in Azure SQL, a lot of people don't really know about, on by default. Imagine, Anna, you walking up to a SQL server. That sounds like a joke. You walk into a SQL server. You walk up to a SQL server and you say, for this long-running query that's chewing up all my CPU, I would love to see an insight of what it's doing while it's running instead of having to see it after it ran. Well, lightweight query profiling gives you those capabilities. You can go look up in the docs about how to go get insights to that. It's really powerful. And then a lot of people are query plan debugging geeks, Anna. They love looking at things called show plan. You ever seen a show plan with all these complicated operators? People make a living at looking at show plan. All that stuff works. All your query plan debugging statements, all going to work for you in Management Studio, extensions for Azure Data Studio, in T-SQL, all that stuff works with Azure SQL. Now, Query Store being a very important functionality, we released in SQL 16 and in the cloud, it's on by default. And in fact, it lights up some very important capabilities that we have, like new performance visualizations in the portal and something that we're going to show you later for auto indexing. So Query Store being huge, giving you deep insights, but just look at this list right here. I mean, this is the stuff people use in SQL Server today, Anna. And it just works, whether it's outside of SQL or inside SQL.
Yeah, it definitely just works. And improving your performance has real benefits. You could, maybe even scale down. And I think we're going to talk about that and save your company money just by helping with these things that many folks have been working on for years. Bob, I always joke that you're hyper focused, and I say things like, okay, now time for some hyper focusedness. And I think our viewers would love to hear a little bit more about the specific things that they might want to consider when it comes to performance and DMVs or extended events. Can you geek out with us?
Yeah, I mean, I remember, Anna, you using that term like on social media, hashtag hyper-focusedness or something like that. And I remember showing that to my wife, Ginger. And I said, is that a compliment? She goes, for you, Bob, it's, Bob, she just patted me and go, just take it. And just roll with it, man. It's a compliment, right? It's a thing, right? Hey, listen, I spent my career at Microsoft with this functionality right here, DMVs, Dynamic Management Views. And so for Azure SQL Managed Instance, here's the news for you. They just work. Everything you have today for all SQL Server DMVs works as is today. So just take your scripts, put them in managed instance, and just run them. And Anna, there's a new DMV for managed instance. This is pretty cool. So inside SQL, you can take a look at the overall resource usage for the managed instance itself, CPU, memory, IO, everything. That's pretty important because you may take a look at that and compare that to the service level objectives, the resource limits for your IO, CPU, and everything you want to do. So that's Azure SQL Managed Instance. All the stuff you know and love, all going to work there. DM exec request, OS wait stats, all work. Now, Azure SQL Database, little different in this way. Remember, we don't expose the entire instance for you. That's the whole idea. But we do expose most of the common DMVs that you need. So you want to look at blocking problems, you have the DMVs to go do that. You want to look at procedure stats, query stats, you can go do all that stuff. You can even do OS wait stats. So it's going to feel like a database to you, as it should, but most of the ones you need to do common things are all available to you. And just like with that managed instance, we're going to give you new DMVs. They're going to give you resource usage for your single database, or even for like an elastic pool of a series of databases. So you just see this right here, and you can tell that I'm going to be able to use the things I know and love today in Azure SQL. Now, there's some things you should be aware of that are interesting. For example, when you look at IO latencies, you may be used to looking at some things at the operating system level. Well, remember, it's platform as a service. So IO virtual file stats, which we've exposed in SQL Server for years to give you IO latencies specifically for the files for SQL, that's there for you. So you have that capability of looking at those things at a database or managed instance for the files that matter to you. And SQL Server performance counters, specific one just for SQL, a lot of people I've talked to don't realize we have a DMV for that you could use, and that's lit up in both Azure SQL Managed Instance and Database. So batch requests per second, anything you're used to seeing, you can see there. But the other cool thing is, though, you're going to see that show up in things like SQL Insights. Now, I love these last two DMVs over here, Hannah, Instance Resource Governance and UserDB Resource Governance, because I've talked about service level objective being these, CPUs and IO and rate, log rates, and all these kind of type things, IO latencies. But I would like to kind of see that at a configuration level, like through T-SQL, right? Rather than just looking at a table in a documentation page, could I run a query to see what is my max DOP that I'm possibly set up my system? Well, those DMVs get to show you that. And then, yeah, you're going to want to geek out. So you want to see some really internal DMVs, stuff that we use to look at the deployments going on to solve problems. We use these. And like resource governance, resource pools history EX, wow, what a mouthful. That's a good example of something where I'm going to show you an example where you can use that and monitor what we're looking at there, because it's kind of a polling DMV to look at really interesting things like log resource usage when you're looking at your log rates. So we have the DMVs you need. We have new DMVs for certain scenarios for the cloud. This is a great story because this is one of the tried and true tools of SQL Server performance, and I think people have what they need here. Now, extended events, our new tracing capability that we've had in SQL Server since 2008, and we pivoted from SQL Trace and Profiler over to this with SQL Server over several last releases and in Azure SQL as well. So you're asking yourself, well, do I get tracing with Azure SQL? Azure SQL Database, most of the common events and actions that you need, I've looked at all of them. The ones you need for monitoring Azure database and tracing it, they exist. Now, targets is where you place your extended event data. It's where you are going to go send your data. Ring buffer and counter exist, but what about file targets, which is usually what you want to do? Remember, you don't have access to the file system directly. So what do you use? Use Azure Blob Storage. Azure Blob Storage becomes your disk drive, per se. When you need things like auditing, we talked about that last week in security, or extended events. So you're going to store your Azure SQL Database extended event sessions in the Azure Blob Storage file target. Managed instance, it's a complete SQL server. So you get all the events, targets, and actions that you have in SQL Server just comes with managed instance. Everything you need exists there. But just like Azure Database, file targets, you don't have access to that file system, right? So your file targets are going to go to Azure Blob Storage. So again, if you think about Azure Database and then you go look specifically at managed instance, you have the things you need to do extended event tracing. And we're going to actually use that ourselves in other things like SQL Insights and other type of tools. But if you want to use these trace capabilities, they exist. Azure Managed Instance even has a few new events that are specific to Azure that you wouldn't see in a SQL Server. So I love the story here, Anna, because I have both DMVs I need and extended events I need. Looks just like SQL Server. Maybe in some cases, like in database, you may not have everything, but I have found, like in the Azure database case, all the things I normally use exist there. So it's a good story.
Yeah, definitely. And I think people are going to be really excited. I mean, I think we're always well received when we talk about DMVs and extended events and how, for the most part, it's just SQL, except in some of these occasions where we even added more events or views for people to look at. Now, I want to go through like a typical kind of scenario. So, let's imagine, you get a call at 2 a.m. Maybe this happened to you when you were working in support, and there's some performance issues with someone's SQL database, and you're on the hook. What happens now that we're in Azure SQL Database or Azure SQL Managed Instance? Can you walk me through kind of like the decisions that get made and what I should go look at and how I should deal with this?
Sure, Anna. But remember, I got paged at 2 a.m.
Oh, paged.
Paged at 2 a.m. I didn't get called. I got paged. Do you know what that is? Pager? No, you've never seen it. You've seen it. You've seen it at the Smithsonian. You told me. You went there and you actually saw it there. No, I give complete credit to this concept, Anna, to Keith Elmore, my longtime colleague, and he's still in support at Microsoft. Known Keith for so long. We've been almost at Microsoft the same time together. And Keith's just a guru on performance. And I remember having this conversation so many years ago when we talked about this concept. And it was at lunch with Keith. And I said, Keith, I just love errors. And he had this weird look at me like, you love errors? Like, what's your function? What's your problem? And I said, I love error messages because I can go to the source code and find exactly what caused an error message. What are those conditions? And debug a customer's problem and find out exactly the cause almost every time. But in performance, no one ever calls and says, oh, by the way, I have a specific query plan operator that's not performing correctly. They just say it's slow. I don't even know what to do. It's a very vague description. So Keith constructed a very genius way, which we still document and use today. Is it running or waiting? And it all starts, Anna, with checking your resource consumption of SQL. So today you do that with like Perfmon or maybe a Linux tool or so forth. But how do you do that with Azure SQL? Well, we have these DMVs we just mentioned that you can take a look at, or you can look at the Azure portal, things like SQL Insights we're going to show you. You can look outside of SQL or inside of SQL to find out what is going on with my SQL deployment. Am I using a lot of CPU or not a lot of CPU? If you're using a lot of CPU, we call that a running scenario, typically caused by what? It's caused by queries that are executing and using a lot of CPU. Could be a bad, inefficient query plan. Could be, though, that maybe you have a lot of queries that need a lot of CPU. You don't have enough CPU resources for your workload. And you might see something called an SOS schedule yield wait when that happens. You could use the query store. Look at the DMVs. There we go. Here are some DMV names you're familiar with that you might use to go look at a problem like this. So that's the running scenario. And typically what happens is you go down and find out what queries are causing this. If it's not enough CPU resources, you get more CPU resources. I got a really cool story to show you on that one for Azure, though. It could be that your query plans are inefficient, so you might debug and make changes there. Now, what if it's not running? What is it? Well, guess what? It's waiting. And it's waiting on several different types of resources. And it could just be a blocking problem. Or it could be something called a latch wait. Maybe it's waiting on I/O resources. which you've seen before in SQL Server. You could see it's still in Azure SQL, which means maybe you need a new deployment option or bump up vCores to get more I/O capacity for your workload, or it could be query tuning opportunities. What do you use to take a look at it? Well, you use these common DMVs that you're used to using in SQL Server, or you're going to use the query store to look at this and find out who's waiting on what are the top wait types I have, how long are they waiting on, go find what those look like and try to resolve the problem for there. So Anna, this is how, quite frankly, I have found success over the years of breaking down almost every SQL Server performance problem, and we have a lot of experience doing it, and we've been very successful doing that here with SQL Server, and you can see now with Azure SQL, it's a very similar process.
Yeah, and I think this is really, really helpful, and it's also probably pretty useful to kind of see what different DMVs you might use or what tools you might use to actually diagnose this. I think it would be really cool, Bob, if you could show us an example of you kind of monitoring performance in action.
Absolutely. Let me share my screen here, and let's do that. So through the magic of screen sharing, here we go. Screen share, and okay. So Anna, here is a computer. It turns out this is a client of mine, a client with a virtual machine. And I'm going to do this. I'm going to kick off a workload using the popular tool called OStress, another Keith Elmore special, by the way. And we've used this for so many demos that we're doing. So I'm going to run this workload, and I'm going to go with SSMS, and I'm going to use the DMVs you're used to seeing to monitor its performance. Now, you're going to notice very quickly something interesting about this pattern here. Number one, notice how many of these requests are in a state called runnable, and how many are waiting on that SOS schedule yield wait. This is a pattern that's happening over and over as I'm running this particular workload. Now, I mentioned a new DMV, DMDB resource stats. Let me run that one. We will pull automatically for you resource usage behind the scenes. Can you see a problem here? My CPU percentage is going up pretty high very, very quickly. In fact, I'm going to run this again because what we do is we automatically just pull this for you every 15 seconds. You see the results of it. Now you can see a pattern emerging here, right, Anna? You can see I'm using CPU a lot every one of these intervals right now, right? So I can maybe tell based on my experience and that scenario I just said, high CPU, SOS schedule yield, it's probably what I call a running problem, okay? Now I'm going to go back and look and see in this particular case, this query is still running now, and I run this again, I still see the same pattern, but it looks like it's kind of going down a little bit, which probably means that the query is almost done. Notice it's down to like 66%. What I'm doing is I'm just running a bunch of concurrent queries that need CPU resources. The plans themselves are fine, but maybe I don't have enough CPUs for this just by looking at this information itself. So let me go back over here. I'm going to see, Anna, that this query finished, and just kind of bookmark and keep that in your head here, a minute 16. So I'm going to show you an additional tool. It's available in SQL Server. You've seen it before, called Query Store. I'm going to look at a report called Top Resource Consuming Queries. And if I click here, this is the query I'm running. Now, if I hover on the query plan here, I can quickly tell something here. I can see that the average duration in milliseconds is only 3 milliseconds, 3.4. And you're like, well, that's not that bad. But look how many times I'm running this thing. I'm running this thing a bunch, almost 200,000 times. Great example of me running a query that uses a lot of CPU for a short period of time, but I run it all the time. So it looks like I'm consuming CPU the entire duration. Now, I can also look at query wait statistics. Now, you're going to find this interesting. Sometimes you can be running but waiting, and you're like, that doesn't make sense. Well, I'm waiting on CPU resources. That's what SOS schedule yield kind of looks like. In fact, the average wait time for each query is that. That's almost the entire duration of the query. Well, that's kind of crazy. So it is a running scenario, but the reason we're waiting on this resource is because we only have so many schedulers to schedule your work, because we only have a couple of CPUs. How do I know we only have a couple of CPUs? Funny you ask. Let me go in and look at this query. This is using that do DMV to see what is my CPU limit for this database. And sure enough, here's the answer. This is that service level objective. It's an Azure SQL database, general purpose, Gen 5 hardware, but only 2 CPUs to run this. And you can see this another way with database property EX down here as well. So this is me, besides just looking at the portal, looking at the documentation, I can tell how many CPUs I get from just looking at this. Now, I'm going to later on in a demo do kind of a scaling thing. So what I want to do is I'm going to flush my query store database so I can kind of compare and contrast. But Anna, before I do that, I'm going to flip over and show you something else. That's inside this VM. So let's go look at the Azure portal and look at this. Okay, so this is in the Azure portal, this database, and I can tell right now, I can see I have this 100% utilization going on. That's interesting, of course, but how about something new? Let's go look at this view. This is SQL Insights. Okay, this is my new SQL Insight I'm looking at here. Let me refresh this real quick, and I'm going to see a similar chart, I'm seeing a similar percentage of my usage in SQL Insights, but look what else is here. CPU, memory, IO, processes blocked, data IO, wait stats, a rich set of telemetry. Remember, this is outside of SQL. I'm looking at this in Azure Monitor with SQL Insights. That is pretty amazing. Now, Anna, there's more. There's more to this story. That's just my database. Let me see here. Let me click here. Let me get to this one. No, let me flip over. I'm going to get to this screen right here. This is my SQL Insight set up for 2 databases in Azure. That's actually pretty impressive. And then when I bring up these databases in 2 different servers, and notice here, I look at all the stuff I can start playing with here. I can get all sorts of things. I get transactions per second, batch requests. Oh, this is looking pretty cool, isn't it? Is this impressive?
Yeah, this is
block
pretty cool.
Processes, deadlocks, and then I look at space usage. I get transaction usage. Here's what I really love. You really want to geek out? Go to Explore Metrics. This is going to feel like Perfmon to you. So look at all this stuff. You're going to scroll down and see. You can start doing whatever you want. And then because this is part of Log Analytics, you can create custom workbooks to make any view you want. This is our default GUI view for you, but we have all this rich telemetry that you can customize and make and then pin it to like your portal. Now, it doesn't stop there. Those are Azure databases. Anna, here's my managed instances that I'm monitoring as well with databases inside it. And then it goes further. How about SQL Server and Azure VM? I can do that too. And then if I want, and I haven't set this up yet, I can do the read replicas of my availability groups as well, all in a single profile, all from a virtual machine that's monitored using Telegraph. How about that?
That's pretty cool.
Yeah, great stuff. We just announced that in public preview. Check it out. It's really powerful stuff. I'm really excited. Every time I show this stuff, I kind of get excited because I just see so much rich telemetry that I can organize any way I want to do that.
Yeah, definitely. I mean, I think it's really interesting, and I've played with it a little bit, and it just seems like there's so many different things you can go look at, and you can even go build your own custom workbooks if you want. So I think, people are really going to continue to like this. We've seen some examples. We also got a question in from Michael, so I thought maybe we'd take a second and take a look at it. The first question, actually, now we have a few questions, but the first question from Michael says, are there available queries that will tell you how much CPU IO network your queries are using and how much you are paying?
So you don't do query, you don't look at pay or your billing at the query level. You look at your billing at the compute and storage level, right? But you can correlate this a little bit, right? Because you can go look at what queries are using most CPU to find out, okay, this is how much CPU I'm paying for. Well, what queries are consuming the most CPU during that range of what I'm paying for? So you can do that for sure. And we just showed you the rich capabilities of SQL Insights. I get all sorts of deep information there about everything about my deployments. And then Anna, we're going to show you later in the session about how through a vision. I showed you how to look at queries with Query Store, like in Management Studio. How'd you like to see it in the portal? So I'm going to show you later in the session how you're going to get that query insight look at that level in the portal, which again can show you historically which queries are using the most CPU. And then you could go look at your subscription and say, okay, during that time range, how much did I pay for that? So you have that option. And don't forget, Anna, you mentioned this before. We talked about this earlier, that serverless, gives you the option to only pay for the compute you actually use. So that's a really cool option that where you're not using your server and you're not using any compute, you can actually have your database pause and not pay for any compute. So,
Yeah, definitely. Thanks, Bob. I think hopefully that helped Michael answer your question. The second question I'll take, it's from Rashad. Rashad said, this video is part of a series which covers the first learning path of the Azure Database Administrator Certification, DP300. Is this enough for sitting in the exam, or do I need to go over the remaining 6 learning paths? So from our experience, Rashad, and this isn't really any official guidance, but from our experience working with people, they have said that by going through just that first learning path that's recommended, the Azure SQL Fundamentals, which has 6 modules, and sitting in one of these series with us, they've been able to pass DP300 without the other learning paths. But that being said, the other learning paths have some really interesting and useful information. So, I might still, depending on your expertise, you might still consider going through them. So hopefully that helps, Rashad. Okay, so we've talked about a lot today already, Bob, and we still have quite a lot to cover. The next, we're going to talk about some performance scenarios.
Yeah, I mean, again, we talked about, is it running or waiting? And that's absolutely true. I mean, that is going to apply here. But there are some things that we discovered. Remember, Anna, if you think back to the history of this, we were assessing SQL Server and comparing that to Azure SQL. And then we said to ourselves, okay, are there any running or waiting scenarios that you just see in the cloud that are really specific to the cloud? And so this is kind of important to call. And the very first one's the most important one, and that is log governance. In order to meet service level agreements and to our service objectives, you just can't use unlimited transaction logs to just whenever you want to do it. We have to govern this some. And so when that happens for, say, an Azure SQL database, say general purpose tier, you're going to see a new wait type called log rate governor that may show up. This may impede your performance, some of your applications, but for a very good reason. Or you might see it show up in other manners with these other different wait types. And so we'll do a demo in a second to kind of show you. I want to call out here a little bit, though, that your log rate that you get is based on the deployment choice you picked. So, for example, business critical is business critical. So we're going to give you more log rates there than we would say in general purpose, or hyperscale has really high log rates, right? So log rate that you need may depend on your deployment choice, but also remember that you could have bursts of this, right? You may have like a huge bulk operation that needs more logging, whereas your normal usage may need a lower log rating. So you need to kind of monitor and see what the needs are of your application. But again, so bulks could be using a lot. You may end up potentially, changing the scale of this as you need, depending on what type of workload you run. So log governance being one of those very first ones. You don't see that in SQL Server. You only see that in Azure SQL. Now, worker limits are interesting. The reason I called the worker limit is that for managed instance, today worker threads look just like SQL Server. So a lot of people may run out of workers and see thread pull weights. Don't forget that when that scenario happens, it may just be a poor application blocking problem, not because you don't have enough worker threads. Don't feel like you got to go bump up worker threads just because you see that. But the symptoms look like that, thread pull weights. Azure SQL Database is different today, at least. We have concurrent worker limits, again, based on that service level objective that you can look up. And when that happens, you get an error. So this is a new app thing you kind of take a look at. You may have run out of the concurrent workers that you need for your application. And so an error may come back to your app, which requires you to do a retry. But it could be you need to go look at, maybe you need to bump that limit up, or again, it could be an app issue that you need to resolve. But keep that symptom in mind. And then you have business critical HADR weights. Anna, you had a question about this one before?
Yeah, I did. When we first started working on this, I was doing some performance testing with business critical, and I started getting these HADR weights. And I came to you and I said, Bob, why am I getting these?
Yeah, and I didn't understand I remember we went back and forth. I'm like, Anna, yeah, that's by design. And you're like, no, wait. I just deployed an Azure SQL database business critical. I mean, this doesn't say business critical or what's going on here, right? So remember what we talked about, and we're going to talk about next week. And I think we got a whole architecture series on business critical, but we're deploying an availability group behind the scenes for SQL Server, an actual SQL Server availability group. So if Anna, today you deployed a SQL Server availability group with like a sync replica, a header sync commit wait is normal. That's like a write log wait. Like that is the time it takes to synchronize and harden the log on the secondary. It may be a low wait time, but it's normal to see that. So I remember coming back going, okay, I get it now. You didn't deploy an availability group, because I remember telling you, Anna, happens when you do AGs. You're like, I didn't do an AG. but you did. You did by doing a business critical service tier. So we don't want people to be surprised when this shows up in their normal weight analysis that we're using at AG behind the scenes. And these other weight types are similar, but they apply to a similar concept where to meet service level agreement, you may see these weight types showing up in how we throttle synchronization to replica. So that's why that showed up. I remember that sequence, went back and forth several times, and finally just got on the phone to get into it, right? So, hyperscale, we talked about some. We'll talk about it next week. The one thing about hyperscale that's really cool is it's a new tiered architecture that gives you great scalable performance, but we introduced some new concepts where we've extended the SQL Server engine. And so things may show up a little differently, but we want to make sure you give you the telemetry you need. So we might, and in this case, we might throttle log rates, not just based on log usage at the engine level, but based on what's going on in the tiered architecture level. We got to make sure our page servers and things are keeping up on track. And if that's not happening, we may throttle the log a little differently. So you might see a weight called an RBIO weight show up. And we document exactly those scenarios. And then because of this tiered architecture, some of our IO goes to something called a page server. And so we're gonna expose some of those IO data to you in DMVs, views, and events for page servers, so you can kind of see what that flow looks like. Whereas normally you wouldn't see that, say, in a SQL server or a general purpose or say business critical. So those are some of the specific scenarios you might see in Azure. So log governance is interesting, and I want to call out to you that we don't have this today in our Azure SQL Fundamentals lab. It's something we added because we said a lot of people had questions about exactly how this works. So if you don't mind, let me flip over and show you a couple of things about log governance that you might find interesting here.
That'd be great.
Let's do the screen sharing again and just double check with me, Anna, and keep me saying here that you can see this.
Yep.
So I've got another SQL logical server here. I've got a couple of databases. I've got a general purpose database here that's 8 cores and a business critical that's 8 cores. And so let me flip over and show you a couple of queries here. So first of all, if you look at the general purpose one, I'm going to look at this here. I'm showing you some of the queries that you can use to look at log governance. So first of all, this first one is looking at that same DB resource governance query. And notice here, I'm looking at what's called the log rate. So the log rate can tell me, for this general purpose, I get about 36 meg per second, right? And weight stats are still applicable. So let me just do this. Let me clear this. And what I'm going to go do is I'm going to run a workload. Now, and I can't help myself, though. I love my sports teams. So there you go. I'm sorry, but there's the table we're going to use. We're going to run a select into, and I picked this specifically because it's a parallelized operation. It's parallel operation here, kind of doing a bulk type insert. And so I'm going to go look at log governance, and I'm going to go look at these weight stats here, and I'm joining more DMVs that you might not normally see. Now, why am I doing that? Because since it's a parallel operation, exec request won't show me everything. So you can see here just by looking at this number, it's a parallel task that's running, but in some cases, the parallel workers are getting throttled on log rates. Now, I may want to see, am I hitting my limit just by running a workload? And I can see that through DMDB resource stats with a different column that I showed before. And maybe you can see now, Anna, that we're almost hitting 100% of the limit that we were given based on the service level objective that we used. Now, I was going through producing this, I asked myself, well, how much I'm using? Like, how can I tell before I hit my limits? This is where I'm picking that geeky one, that one we showed before called workload groups history EX. I'm going to run that query here, and I'm looking at this, and I can see now my log rates look like I'm approaching that limit that we're throttling on. So I can look at the overall weight stats when this is done, and this is finished now, by the way, and I can see that log rate governor, I've had several weights on that at a certain average wait time, per query. So if you go over and look at, say, business critical, what does that look like? And it's the same number of cores. So I'll go look at the business critical one, and I see this limit here. And I'm not going to run through the whole demo here for you, because what you're going to see here, I have 96 meg now. That's almost 3 times as much, right? So if I run that same workload now, I'm going to find out that I have just a few log weights going on for log rate governor. I can run the same set of queries here and observe that I almost don't wait at all. And in fact, if I go look at the select into, this thing took like, if I go scroll down here, this took like 47 seconds. If I run the same exact thing on the same database in business critical, it takes like 10 seconds. So it just shows you that for performance throughput for log rates, for like a bulk parallel operation like that, I'm pushing the limits of my log and I may need to go to a different service tier. But keep in mind, maybe I don't do that all the time. So it's not like this log rate thing is something you always may run into, but if you see it, I want you to be able to recognize it, how to go diagnose it with the tools through DMVs, and then decide like, how do I deal with it?
Thanks,
so that's
Bob.
log rate governance.
That's a great demo. I really like that demo, and maybe we should look at maybe getting it added to the series so people can get hands-on with it as well.
Absolutely. We should, yeah, those scripts are, I should just share those scripts out. You're absolutely right. We can put them in our GitHub repro and make those available to everybody. I agree.
You didn't know I was going to assign tasks to you during this live series.
This is very much like you. Usually after one of these assignments, it's like, Bob, can you go off and do this or do that and do this? So, by the way, that's a complete lie. Anna does so much work behind the scenes for this. I know I sound like I'm whining here. So, where's the cheat with that whine, right?
Oh, I'm just giving you a hard time. But it seems like, people are really, really receiving all this really well. We're getting a lot of comments throughout all our different streaming platforms, especially on Twitch. People really took liking to someone walks up to a SQL server, and we've got quite a few jokes that people have come up with.
People come up with some interesting jokes for that one, right?
Yeah, exactly. So again, we've been talking about a few things. We talked about monitoring and scaling. I'd love to talk a little bit about accelerating and tuning and some of the things you've learned from working with SQL Server and Azure SQL.
Sure, thanks, Anna. Again, we told you about problems. What about solutions, right? So when it comes to scaling, notice the problem we just presented to you. We presented you a problem that we think that we may need more CPU capacity. Now, Anna, here's your problem. You manage a SQL server on a virtual machine that's hosted with a bunch of other virtual machines in a hosting environment or in your data center. And you run into this problem. And you're like, I need more CPUs. Oh, no problem. This is a virtual machine. I'll just get more vCores. You may not have permissions to get more vCores. Or your administrator says, we're out of capacity on this server. So can you just migrate your VM and your database to another server? And by the way, that might be a month from now. And you're like, no, my business is down. Like, this is a problem, right? Hey, here's the cool thing about Azure SQL. You can scale CPU capacity dynamically, very easily with general purpose or business critical or even hyperscale using the portal, using T-SQL. I'm going to show you that, PowerShell or REST. And the downtime can actually be very fast with no migration required. You don't do the migration part. In fact, what we try to do when we scale this is we wait to the last possible second to shift you over to this new deployment so that your downtime is very minimal. And then auto scale, what about serverless? So you want it dynamically scaled, like what I just showed, for this 2 CPU problem? You wouldn't even have to scale it because you could pick a range of CPUs with serverless and we just do this automatically for you. And then hyperscale, it's just like general purpose. We should call it the fact that hyperscale is like general purpose here, where the data files are in remote storage. The scale can be very in constant time, unlike business critical. One of the issues with business critical and scaling is that the databases are kept on local storage. So trying to find another set of local storage and then get replicas synced up and everything going for you could take a little longer if it's a very large database. But for hyperscale general purpose, the scaling of CPUs can be in constant time, whether it's 2 or 80, which is pretty cool. So that's CPU capacity. What about I/O performance? Like, how do I get that faster? First of all, you should know what IOPS are. Like, if you don't know that concept in your data center and your SQL server, go figure out how to measure IOPS. Look at I/O, things like disk transfers per second, things of that nature. And sometimes when you have restriction on IOPS, they show up in form of longer I/O waits in SQL Server, page IO latch waits or write log waits. So understand what that looks like. Look at our service tiers, look at our slows. It shows you the IOPS you get for your deployment. And then if you need higher IOPS, it's usually a scaling operation. You go to more vCores, or some cases you need to move to a different service tier to get a higher IOP rate. Now remember, in any things I'm talking about in these scenarios, CPU or IO, there could be query tuning opportunities, right? This is assuming you've gone through that process. So IO latency can be critical for very high-speed transaction processing, right? So if you don't have a good enough latency story with your deployment for, say, Azure Database general purpose, maybe you need to go to business critical or hyperscale, where we're going to get lower latencies there for you. Or same thing in managed instance. And don't forget, though, we mentioned earlier that changing files and file sizes can give you faster IO performance in general purpose for managed instance. And then finally, don't forget about multi-statement transactions. I've seen people literally take a singleton singleton loop with insert statements on their laptop and go run that in Azure Database Business Critical and go, see, Bob, it's not as fast as Azure. And then I'm like, hey, man, I get it. But I mean, do you have like an auto DR system set up on your laptop with service level agreements and everything behind the scenes? Or you probably don't. So it's not a fair comparison, right? So if that's the case, though, when would you ever run that in your actual workload? You usually use multi-statement transactions. So I have something, Anna, that's not even in the, I don't think it's even in the fundamentals, but in our GitHub repo, where you go through the process of looking at application latency for logs with your transactions. So we talked a little bit about workers, but what about memory? I didn't really even mention about how to get more memory, right? Well, I did kind of say that, and that is the fact that you don't just go use max server memory or something like that. You actually use vCores typically to scale up. It's a similar story with like temp DB files. The more cores you get, the more memory will give you for your application needs. So scaling up gives you higher memory limits, and we document what that all looks like. And then don't forget about application latency. And I only say that because of our experience we've seen. Anna, you've seen this before. You've mentioned before this concept of redirection versus proxy. I was blown away by the speed difference between those two, but it kind of makes sense based on that concept. The fact that you don't have to go to that gateway every single time you're running a query. And then this is one thing we've seen, especially when people are in their own data center. Sometimes they get away with performance with chatty applications. Seen people not even use stored procedures before, move to the cloud, say their app is still on premises, and all of a sudden now they're across the internet and running into performance problems. So look at those chatty application issues. And here's one of the most important parts of this slide, Anna. Tune your queries just like you would SQL Server. Indexing, batching, procs, parameterization, even processing results in a timely fashion. These concepts that are tried and true, which is part of the skill set you have today, they still apply in Azure SQL.
Awesome. Yeah, this has been really useful, and I'd love, again, to toss it back to you to take a look at how that previous problem we were seeing, where it took, I think, 1 minute and 36 seconds, how we might be able to address it and scale performance.
Yeah, it's kind of like not finishing a novel, right? Like we got to finish the story here. So let's go back to the VM we were running. This is the one we were running when we were doing our log governance. Let's go back, though, to the workload we were using. Remember this one. Here's that minute, 16 seconds. And I told you that we were running a 2 vCore. Let's get that back up. This is the database. Now, I don't want to confuse everybody. This was my server for my log governance. This is my server for the scaling scenario. We're using this database, AdventureWorks Azure LT, a non-sports reference, Anna. There you go, a non-sports reference for you. So I'll run this again. Remember, this is 2 CPU. So what I think I need to do is go to 8. That'd be kind of cool. So can I do that to T-SQL? I can. So I'm going to go here to modify service objective. Look at that. Altered database has been modified in the cloud to scale up. So let me just run this thing. Whoop, I scaled up. No, that's not true. So
not that
what's
fast.
happening here, this is like a deployment operation in Azure. So if I kind of go over here, maybe look at the portal real quick, you'll see here, it says updating pricing tier. And I know, Anna, sometimes it can get a little confusing for people. The pricing tier is where you go make changes like the service tier and your vCores and everything. And instead of using the portal, I just use Azure Database. And this is just showing that behind the scenes, I'm changing it. Now, the database is still available to me, even though this is going on. This is a very quick operation that happens. And once this occurs, I can go back over here. Let's kind of go back over to our VM. And then what I can do is go back to this get service objective query and see, do I have 8 CPUs now? Oh, look at that. I do. In fact, you can see here now, I'm at that 8 CPU limit. So what would be kind of interesting to see is that, do I have to change any code to get faster? No, I just went to 8 CPUs with a declarative change. I ran this workload, and now let's go back and look at the DMVs that we were kind of monitoring before. So what about exec request? What does that look like? And this is the behavior of a better scaled operation. Notice here, more running statuses. We have a few runnable, so we even have more scaling opportunity, but more running statuses and less SOS schedule yield weights are occurring with this workload. And then we're showing you the DMDB resource stats, which was the Azure specific stuff. Let's run that. And you see here that I am still using some CPU, but I'm not hitting that 90% like over and over and over and over that's running. In fact, I suspect it's even finished. Sure enough, I can go over here and see that. I went from 1 minute 16 to 28 seconds just by making that one change in altered database. But I'd even like to go further in my monitoring. Let's go to Query Store and see what it looks like. So let's go to the top resource consuming queries. This may fool you a little bit here in the sense that the same query is showing up with a different query ID. That's because inside Query Store, the first plan, Anna, was running on a 2 vCore. It wasn't possible to run it in parallel. And so Query Store is going to record this as 2 different queries, even though it's the same text. So if I click here and look at this plan now, this faster one, right, you can see from the graph. Remember the average before was like 3.41 milliseconds. I can see here the average duration is like a millisecond. I'm running the same number of executions, but I'm like 3 times faster just by doing that small scaling operation. And then I've demonstrated this. I think we did this even during one of our earlier modules. If I ran that same demo with serverless, it would have just scaled. I wouldn't have had to do anything. So what I'd like to do is also just go back and see, you know, what does this portal show me? I mean, is it any different? So let's go back here and see. Now you can see here, let's go back and go here. Sure enough, you can kind of tell the graph. It's still using some CPU, but it's less CPU than I had at this pure 100% story. And then this is the really interesting part. Like, what does SQL Insights show me? SQL Insights, still loving it. It's still showing as well a smaller CPU. The graph is kind of further out. In fact, let's go pull it out. Maybe the last 30 minutes, the last 30 minutes can show me both graphs that we're actually running. So here, me showing SQL Insights. I'm looking outside SQL. I'm going inside SQL with the Query Store. I'm looking at for both angles now. And I think I've shown you, I've got the telemetry, the tools, everything you need, and I can scale pretty fast with no database migration on a common performance problem.
Yeah, I mean, it's definitely really cool to see what you can do with the tools that most people have already in combination with some of these other things that make it easier to do that, like T-SQL, so you can just run an alter database command, and SQL Insights. And the fact that, like you mentioned, and maybe some people miss this part, is we're going to keep you online as long as we can, even during the scaling operation. So you just have a minor blip, which I think is different from what would happen otherwise if you weren't running in Azure SQL. So really cool. And, you know, Bob, we have, 15 minutes left, and I think it's really important we spend some time talking about intelligent performance. Now, there's some capabilities from SQL Server that people might be familiar with, like intelligent query processing and automatic plan correction. But because of the telemetry that Azure SQL Database specifically has, there's also some machine learning that we can do to make you run even more intelligently and help you with performance. I'd love, Bob, if you could spend some time and take us through it and maybe even show us that last one.
Absolutely. Just keep in mind one theme as you're looking at this. And if you could kind of go to the intelligent query performance slide there, Anna, I think it's going to help people resonate here. Here is our idea. We want to get you faster and not change your code. Anna, you're a developer. You kind of like that one, right? Like, I just want to get faster and I don't want to change any source code. Don't change my stored procedure, any of that kind of stuff. Why can't SQL Server just do that? Intelligent query processing is one of those options under this intelligent performance umbrella. It's built into the query processor engine, Anna. This is something you just don't turn on like some feature switch in the cloud or a checkbox. You do need to go to a new compat level for your database to take advantage of it. But it's almost like you change your compat level and then the engine now recognizes all these different scenarios. These scenarios are not things that we just made up in an office somewhere. Joe Sack is not just sitting around in his office going, I think I'll do memory grant feedback. Joe's going to love that comment. I'll probably hear from Joe later on that one. But the idea is this. These are real world customer scenarios. Some of these you may even recognize where support team has told us about it. We've seen it in benchmarks. We've seen it from customer interactions. We've baked this into the query processor. We started this journey in SQL 17 and in the cloud with DB Compat 140. You see that on the left-hand side. We continue that journey on the right-hand side all together with 150. And we're still working on this. This is like a journey that we're not done with. In fact, it kind of is our goal not to ever have to show you this tree or something. But we want to make sure we tell you what we've lit up and help you get faster. Why? We had customers that got faster in SQL 19 and didn't understand why we had to show them this. This is what happened to you, how you got faster. So again, built into the query processor, no code changes, right? In the engine itself. Now, automatic plan corrections, a little different. It is technically part of the automatic tuning family for Azure SQL and SQL Server. And the idea being is that it's all about query plan regression problems based on the query store. So in the query store, if you've got that turned on, we can recognize if a query plan caused worse performance than it did before. Notice the plan 2, plan 3 comparison. And if it did, we can tell you about it. And then if you'd like, you can turn on automation or automatic plan correction, and we'll just revert back to the plan that was faster. Okay, that's on by default for Azure SQL Database. And you can see the results of what we've done through like a DMV. Again, all based on the query store. A good example of us lighting things up in the query store. We've had an Azure SQL for a few years, also existed starting in SQL 17 and in SQL 19. What's really interesting in the class, oh, Anna, here you go. Professor Anna, Anna has to make sure everybody understood what we were saying. So let's all play along with Dr. Anna on a Monday and make sure we got it right. Here we go, Anna. You're going to trick them. I'm sure you're going to trick them. So go ahead. Go ahead.
Oh, man, that was good. Surprise, we're going to do a knowledge check.
Surprise, yeah.
Okay, so you all should be seeing this up on Learn TV, but basically we're just going to take a quick second. I think I have two questions. Which best describes intelligent query processing, or IQP? So this might seem like a simple question, but you maybe had to have been paying attention. So we're going to take a quick moment. Go ahead and get your answers in for this question. And then we'll move on to the next question. And then we'll get on to that very exciting topic that Bob was ready to get into.
But I mean, this is just like being in class. I remember in college where I'm ready for the end of the class hour and my professor throws up a pop quiz. That's what you're doing here, basically. Yeah. Are you paying attention?
It's a fun pop quiz, though, right?
It is a fun pop quiz. I agree. Let's see what's happening. What is everybody saying, Anna?
It looks like most people are saying C, and then a few people are saying A. Bob, you want to go ahead and take people through it?
Sure. Remember IQP being a query processing in the query processor. And the way you light this up is through database compat level. So it is definitely not A, because it has nothing to do with that. Okay. Now, it could be that statistics help us in query processing decisions, but intelligent query processing isn't us changing stats to make things faster. The query processor makes decisions based on a DB compat level. So it's not A. And it's in the query processor, so it's not a background task. And it doesn't require query store. That's kind of nice, Anna. You don't have to have query store on, even though we recommend you turn it on. It's in the engine itself, so it can't be B, so it's got to be C.
Yes, that is correct. And it looks like about 75% of people got that, so that's good. We still have people. Still have people with us, so thank you for sticking with us. We've got one more question.
Okay.
This one is about automatic plan correction. So automatic plan correction can help recommend and fix which type of performance scenario?
Okay. Yeah. We did talk about this when we just talked about it, right? Yes. I used a certain term when I talked about this technology. That's the clue there. Did everybody got that one?
Well, hopefully. We'll see.
We'll see. Everybody's hanging on. They're like, please, no more polls.
No more polls.
Some people tend today didn't think they had to do any work. They were just going to listen, right? But I love these polls because it really reinforces, are we really getting forth the message that we want to from what we're trying to teach everybody? So I like them.
Definitely. Looks like we've got a few answers in. Most of them are C. So why don't you go ahead and take us through these just for time?
Well, we just mentioned that this is based on the query store, and it really has nothing to do with indexing necessarily. Although indexing may be something that somebody does to cause a problem, really this is not about that. It's about query plan regression problems. So A is not the answer, and B is not the answer either, because it's not about stats, right? This is about query plans that come in that were the same exact query, but a different plan was chosen, usually something called parameter sensitive plans. Also, Anna, called parameter sniffing. How do you like that term right there? There's a huge debate on the internet about who at Microsoft invented that term. People have said, is it Kalen Delaney? Is it Connor Cunningham? Is it Bob Ward? None of us are admitting to who created parameter sniffing as a term. Nobody wants to fess up to that. Parameter sensitive plans, though, that is actually what we're really after. So query plan regressions, that's what automatic plan correction can detect and fix.
Awesome. Yeah, it looks like about 90% of people Got that. Now there's one more area we want to talk about today, and that is only available in Azure SQL Database. Can you tell us about it?
Yeah, I mean, you have a database. We have the ability in those scenarios to put some things behind the scenes to look at not your data, but your queries and your query performance. Like, what if we could take Query Store, visualize some things in the portal to show you, but what's even more powerful, what if we could recommend indexes, Anna? What if we could recommend indexes for you? And then if you were really bold and you just love what we were recommending, wouldn't you like us to just do it? That'd be kind of cool.
Yeah.
So we have that capability now called automatic tuning, specifically index recommendations, the Azure SQL database. I think I should show it to you.
Yeah, let's take a look.
Okay. So here we go. One more time, the magic of screen sharing. And this time I'm going to go over here. I'm going to go right here. You see that?
Yep.
Somebody asked about looking at queries and CPU and getting billing information. And I showed you Query Store with Management Studio. How'd you like to go to the portal, though, and look at this? This is a way for us to show you a rich set of query history per query and look at resource usage over a period of time. We're using the Query Store to do this. But here's what's really cool. How'd you like to see this one? Oh, wait, you have some recommendations for me? That's pretty neat. We can go over and recommend indexes to you now, and we can even show you indexes maybe that we helped you with. We can recommend indexes to create and even indexes to drop. And we can even tell you what we predict to be the impact of creating that index. You can go over to this option. You can do it for your subscription. You can do it for your logical server. You can do it for your database. Notice that force plan is on. That's that automatic plan correction, Anna. But create index and drop index are off. I could turn those on. And if those are on, when we feel like we've got a recommendation, we'll just do it for you. Now, you may say to yourself, wait a second, time out. What if you build an index that no longer becomes good for me? We will still monitor you after creating it, and we'll drop it if we need to. Now, here's a cool story. Anna, you're going to get on after this is over, and you're going to go, I got to get my hands on this. I'm going to go run a really bad query and watch it just create an index for me. It doesn't do that. It uses machine learning algorithms in the Query Store over time to look at your workloads, to look for repeated problems, right? Like if you run one bad query, you don't probably want us throwing an index out there that may affect the rest of your workload and make it bad, right? So we're going to go look over time for these workloads. In fact, when I've had to build this myself and look at these demonstrations, I've had to run something for like an entire day to kind of show the problem. And it's a good idea too, because we don't want to go out there and just build these things at random and make and cause worse performance problems for you. We want to build things that actually are really valuable to you. But let's say you're a developer out there and you're doing an Azure SQL database and you'd love for us to help you with indexing without having to have a sophisticated set of experts doing that. This is something for you. Or you're an administrator and you'd like to see what can we recommend for you first based on you see in the workload. We can do that for you as well. And then even eventually, if you'd like to, we can start applying these recommendations for you. So I love this functionality. It's showing a concept of query performance insight, visualizations in the portal based on Query Store, and the ability to do automatic tuning with index creation and drops, again, based on machine learning and data we're capturing in the Query Store.
Yeah, it's definitely a really cool capability. And again, just to highlight, this one's only available in Azure SQL Database. Is that right?
Right, that's correct. That's only today in Azure SQL Database. That's right.
Awesome. Well, Bob, it's been quite a day. I personally have learned a lot, and I think our viewers have probably learned a lot too. Just to kind of take a step back and think about and talk about what we talked about. We talked about the capabilities. So we talked about the different capacities of CPU, memory, and I/O you get from scaling up or down, or from your different deployment options. We talked about resource governance, and you even showed us a new demo, which we're going to work on adding to our series on log governance. We talked about scaling up. We also got to see that, so folks can get hands-on and see how to do that using that alter database command or the Azure portal or other tools. We also talked about tools, and we geeked out. We talked about the DMVs, extended events. You showed us how you would walk through and analyze a performance issue, whether it's running or waiting, and then how to address it. So that was all interesting, even seeing how the Query Store is on by default. So you could just go in and also analyze what's going on with that. And finally, we talked about intelligent performance, some of the capabilities that folks should be familiar with from SQL 17 and SQL 19, and then even new capabilities like automatic tuning, which are only in Azure SQL database. Now, before I share some resources, can you tell us, now we've talked about performance, what's left in our series?
Well, now that your brain's exploded
Yeah.
with hyper-focusedness, right? I think it's fitting that in the meat and potatoes, even though this is really exciting stuff that we have today, that the last section be about availability. I know when I personally looked at this, it was some of the most powerful technology that we've put into the managed service. And I can't wait to show you guys, and for Anna, you also to show us some demonstrations of how we have built an HADR. I think you're just going to be blown away what we provide you in Azure SQL Database and Managed Instance for availability.
Yeah, it's definitely a fun one. So you're going to want to stick around for it. Just a few resources as we close out today and then tell you about next time. The first one, Azure SQL Fundamentals. This is the learning path we've been talking about. So definitely go check that out. Get hands-on on performance, on security, on everything else that you might have missed in previous weeks. We also have resources here for our GitHub where you can find all these slides under SQL workshops. We also have several different video sources you can follow, like Data Exposed or Azure SQL for Beginners, where Bob and I actually did this series, except over this course of 60 small videos. And then from a books perspective, Bob last year released this book specifically related to translating your SQL Server skills to Azure SQL. So we think it's a very good supplement and even a more deeper dive with some more context to what you learn in this learning path. And finally, we have a book for modern developers by myself and some members on the team. If you're newer to SQL and developing with SQL, I think this is a great option. Reminder that today the Learn module we did was delivering consistent performance with Azure SQL. So you can go there and try all these exercises for free. You can get hands-on on the Azure Sandbox. I know I say this every time, but it's just really great to be able to get free resources in Azure. And, just looking back, you can access all our on-demand episodes at aka.ms/learnlive. And if you want the calendar invite for the next 2 sessions, we'll be back here at the same place, same time. But those links at the bottom, aka.ms/learnlive Azure SQL Fundamentals, is where you can get the calendar invite so you don't miss the next few episodes. Bob, any closing thoughts on where we've been, where we're going, how the series is going as we close out?
Thanks, Anna. Thanks, everybody, for joining today. We provide you a lot of information, but here's what we tried to show you, just like we did with security, just like with availability. This is just SQL Server, but in a very unique way that's a managed service in the cloud. So a lot of your skills are going to translate, but we're trying to give you the knowledge you need to accentuate that and learn how does SQL Server run uniquely in Azure to make it what I consider the world's database. So it's been great to be with you again, Anna, and I just thank everybody so much for joining us today.
Awesome. Thank you.